What up? What up? What up, y'all? We back with another video, man. We live with it. All right, I got the cape out, so you know I'm on my superhero shit. About to go through. Is my do rag crooked? Hold on. Oh dang, I'm against crooked. I'm going the wrong way. There we go. Make sure the Dewey is straight. My bad, y'all. I guess I should have been ready, but it doesn't matter. I'm ready now. Let's go. Let's get it. Full zip. You know what I'm saying? Make sure my audio's coming in clear one time. Okay, let's see what we got going on here. Think somebody calling me? Not now. I'm locked in. I'm locked in right now, y'all. We're gonna go through this CS50. I'm computer scientist, data dog. You heard? We out here. You know what I'm talking about? We really about to. I gotta find my taxes. We get distracted. Okay. Let me get this popping. Damn, I need to put my phone on charger too. Put on do not disturb. You know what I'm saying? Boom. See what we got going on over here. So, what I realized so far with this computer science, it's gonna be a lot of repetition, y'all. Because ain't no way I'm just gonna retain all this information on one go around. So, I will be repeating some things, and it will get real redundant real quick. Okay. And I'm just trying to make sure my audio coming in clearly. There we go. Just gonna set that aside like that. And we're going to rock out. All right, y'all. So we left off last time on conditional statements, I believe. Let's get into these loops. See what they're talking about with these loops, y'all. So let me share my screen with y'all. Share screen, entire screen, and then we're gonna go also share the audio right here, share. Okay, here we go. Let's get into these loops, y'all. We're gonna learn about the loops. My boy Dougie.
Repeatedly. All right, so let's talk about loops.
Let's do it.
So loops are kind of cool because they allow your program to execute lines of code over and over and over repeatedly without having to copy and paste or otherwise repeat them.
Put my notes up.
There are three major kinds of loops in C, and you'll probably have occasion to use each one as you progress through CS50. Some of these loops are pretty familiar to you from scratch. So again, as we did with conditionals, we'll put them up side by side if there is an analogy that we can draw. First is forever from scratch, which compares to while true. This is what we call an infinite loop. The lines of code between the curly braces, much like the puzzle pieces that fit inside the C of the forever block, will execute repeatedly from top to bottom over and over and over forever. After all, if you recall from our discussion of Boolean expressions, true is always true. So if we're doing something so long as true is true, seems a little silly, true is always true. So it'll always run. It'll run forever and ever and ever until we find a way to break out of it with a break statement, which again, we saw a little while ago when we were talking about switch, or otherwise just kill our program. Which incidentally, if you ever find yourself in a situation with an infinite loop and you don't know how to stop your program from running, just hit Control and C, and that'll kill your program for you.
We'll see.
But this again is called an infinite loop. It is a loop that will run forever. Now, while loops are not always infinite, we can also replace the Boolean expression with something a little more useful than just true. So here's another example: while, and then some Boolean expression, and then curly braces. That's pretty much analogous to repeat until from scratch, although in a second I'll explain the difference. So in C,
run that back.
Expression inside of the
run that back.
Than just true. So here's another example: while, and then some Boolean expression, and then curly braces. That's pretty much analogous to repeat until from scratch, although in a second I'll explain the difference. So in C, If the Boolean expression inside of the while loop evaluates to true, the lines of code between the curly braces will execute repeatedly over and over and over until Boolean expression evaluates to false. So for example, you might have some sort of counter. So say you at the beginning of this loop, you say int x equals 0. While x is less than 100, do a couple things inside that curly braces. Then at the end of your loop, you say x plus plus. You're incrementing x. So eventually x will get to 100 and you will stop because the condition x is less than 100 will no longer be true as soon as x is equal to 100 because 100 is not less than 100. Now, somewhat confusingly, the behavior of the scratch block is reversed. So be really careful if this is your first foray into using loops. Basically, the the repeat until block in Scratch will repeat something over and over and over until the expression, the Boolean expression in the hexagon, is true. So it will keep doing it until it is true. Meanwhile, the while loop will continue to do it until it is false. So they're quite similar, but there's that little distinction just to be careful of, especially as you make your first foray from transitioning to Scratch into C.
While
the next kind of loop is actually pretty similar. It's called a do while loop. This loop will execute all of the lines of code between the curly braces once, and then it will check the Boolean expression. If the Boolean expression evaluates to true, it'll go back and it'll repeat that process over and over and over until the Boolean expression evaluates to false. So this loop, unlike a while loop, is guaranteed to run at least one time. This can be pretty useful.
Wait, run that back.
It's to false. And it will check the Boolean, execute all of the lines of code between the curly braces once, and then it will check the Boolean expression. If the Boolean expression evaluates to true, it'll go back and it'll repeat that process over and over and over until the Boolean expression evaluates to false. So this loop, unlike a while loop, is guaranteed to run at least one time. This can be pretty useful. Lastly, we have a for loop.
Let me understand that. The loop will execute all lines of code between the curly braces once, and then if the Boolean expression evaluates to true, we'll go back and repeat the process until it's false. Do while loop will execute all lines of code between curly braces until Boolean expression is false. Pretty much.
So this loop, unlike a while loop, is guaranteed to run at least one time. This can be pretty useful. Lastly, we have a for loop. For loops are kind of syntactically unattractive, and there's a lot going on here, so bear with me as we try and break these pieces apart. Generally, the use case of a for loop is you want to repeat something a specific number of times. In this example here, I have the repeat block from Scratch, which is analogous to the for loop in C, repeating something 10 times. And the for loop on the left there, which is a for loop that would do the same thing. This would go 10 times. We're counting from 0. We increment I each pass through the loop, and we keep doing that until I is less than 10. So what happens? There's a whole lot of code there. Let's break it down into what is happening step by step as we dig through a for loop. The first thing that happened is the counter variable is set, or everything to the left of that first semicolon inside the parentheses is executed. In this case, we are saying int I equals 0, declaring a new variable called I. That variable is of type integer, and we're saying the value inside that variable is going to be 0. The second thing we do is we then immediately evaluate the Boolean expression. The Boolean expression is in the middle of the two semicolons. I is less than 10. That's true here, right? We just set I is equal to 0, and so 0 is less than 10, and so that condition is true, and we will now proceed to execute the body of the loop. If it was false, if, for example, I had said, instead of I equals 0 there, I had said I equals 15, int I equals 15. Well, 15 is not less than 10, so we would never enter the body of the loop because the Boolean expression there would evaluate to be false. After we go through from top to bottom and we encounter that closing curly brace, a third thing happens. The counter variable is incremented, or rather, the lines of code or the statements after the second semicolon inside of the for loop's parentheses is executed. So we start out by saying int I equals 0. Then we check whether or not the Boolean expression is true. 0 is less than 10, So it's true. So we're going to proceed into the body of the loop. Things will happen inside the loop, and when we encounter that closing curly brace, the next thing we do is we say I plus plus. So I was 0, now I is 1. Then we again check the value of the Boolean expression in the middle. 1 is less than 10. So we'll go through this process again and again. We'll finish the closing, we'll get to the closing curly brace again. We'll increment I from 1 to 2, then from 2 to 3, and so on and so on and so on until eventually i's value becomes 10. Is 10 less than 10? No. Counting from 0, we've gone through 10 iterations of the loop. We've repeated 10 times, just as we did in the scratch block. And so that's basically the process for a for loop. Now, taking away the actual code and putting it in some sample, just some basic general statements, here's what happens. All of the statements in start are executed first. You might have more than one. Then the Boolean expression is checked. If the expression evaluates to true, execute the body of the loop one time. If the expression evaluates to false, we're done. We don't execute the body of the loop at all. After we've executed the body of the loop one time, we then do what is in the increment part there, which is usually going to be something like I++ or something like that modifies a counter variable. Then after we increment, we check the expression again, and we repeat those steps over and over and over until the expression is no longer true. So what are the use cases for a loop? You use a while loop when you want a loop to repeat an unknown number of times, but it possibly might not run at all. A really common example of a while loop being used is to run the control flow for a game. You might not know how long the user is going to be playing, but you want to keep doing the same thing, updating the positions of various sprites on the board. You want to keep things moving at all times, but you don't know when the user is going to stop playing or when they're going to run out of lives. So a while loop is really good for something like that. That's a good use case. For a do while loop, it's pretty similar. You want a loop to repeat an unknown number of times, but at least once. You might use this for a game too, but a really common use case is prompting the user for input. Generally, you might say something like, give me a positive integer. And you might put that inside of a do while loop. So it'll always ask them at least once for a positive integer. If they give you a positive integer, you might break out of the loop. You might be done. The Boolean expression in the do while might be false, and you won't ask them again. If they give you a negative number, though, or they type some word or something that's not really useful to you, you might use the do while loop to go back and do it again and again and again. You definitely want to ask them to give you a number once, but you don't know how many times after that they might be pests. And so a do while loop is a great use case for prompting the user for input. And a for loop's use case typically is when you want to repeat a loop a discrete number of times, though you might not know the number of times at the moment the program is compiled. So for example, maybe you have a program where you prompt the user for a number, say, and they enter 100. And maybe your for loop will then in that case run 100 times. Or maybe they enter 1,000. And your program would then run the loop 1,000 times. It's a specific number of times, but you don't necessarily know what that number is the moment the program is compiled. It's not like a while loop where it could be infinite. It's rather a number that you just don't know. Now, even though I've outlined all these use cases, you should know that in pretty much every circumstance, you can interchange all three of these loops. You can use a for loop where you would otherwise use a while loop. You can use a for loop wherever you would use a do while loop and so on. It can be a little tricky sometimes. So generally it's a good practice to adhere to a typical use case. Use a do while loop if you want to do something once at least. Use a for loop if you want to do something a specific number of times. After all, that's why there are 3 different kinds of loops so that they can be used in the right context. But you can interchange them if you want. If you feel comfortable with while loops and you always want to use while loops, it is something that you can do, although it might be a little syntactically tricky, where a for loop would be a lot more straightforward. My name is Doug Lloyd, and this is CS50.
Okay, that was a lot, but we're going to rock through it. It don't matter. Let's see, we got command line. Let's watch command line. We're going to do this one now. And we're just going to lock in, y'all.
Okay, so let's talk about how to use the Linux command line. Now, the CS50 IDE, or in fact, even the CS50 appliance, if you're familiar with that or you're taking an older version of CS50, is a cloud-based machine which runs Ubuntu, which is one of the many flavors of the Linux operating system. Linux operating system is favored by programmers because it's just cooler, right? Many modern Linux distributions have graphical user interfaces, which we also call GUIs, GUI. to allow easy mouse-based navigation, which you're probably familiar with if you're a Windows or Mac user, moving around your mouse, double-clicking on icons, and so on. Still, though, as a programmer, and even though the IDE contains the ability to do some graphical user stuff, clicking and dragging and all that, you'll still be using your terminal window pretty frequently. And you can do many of the same tasks that you can do with a mouse with keyboard commands. And we're going to talk a little bit about what some of those commands are right now. Now, these commands can be used on any Unix-based operating system, which includes Linux, but also includes Mac OS. If you open up Terminal on your Mac, you can do this. You can use these exact commands. Windows also has command prompt, but some of the commands are slightly different, so it doesn't actually work because Windows is not a Unix-based system. So let's take a look at some of these Linux commands. The first one that you'll probably use quite a lot is ls. That's a lowercase l followed by a lowercase s, which is short for list. Now, what the list command does is it gives you a readout of all of the files and folders in your current directory, so you can see everything you can get to from where you currently are. So I've opened up here the CS50 IDE, and I'm going to zoom in a second to give you a closer look, but here's the broad picture of what the IDE looks like. On the left, you can see we have a file tree, which you're probably familiar with, double-clicking and files and folders and all that stuff, so that's still there on the CS50 appliance. At the center and the top is where you're going to be writing your code once you click on a file, and at the bottom, we have a terminal window, which is where we can execute these terminal commands. I'm going to zoom in and head over here just to show you that, in fact, I do have, I can click on these files and folders. So clearly where I currently am, I have two folders called pset0 and pset1, and three files, one called hello, one called hello.c, and one called hello.txt. So let's move down to the terminal window and get a closer look. So we just talked again about the fact that we have three files and two folders in the current directory. If I type ls, which again is the command to list the contents of the current directory, and then I hit enter, look what I see. Hello, hello.c, hello.txt, pset0, and pset1. Pset0 and pset1 are colored blue to indicate to you that those are directories that we could navigate into, and we'll learn a little bit about how to navigate into directories in a minute. And every other thing is colored black if it's a text file or a source code file, and green if it's an executable file. So clearly that means that I could run a program called hello. That's what the green one there means. But basically typing the ls command has allowed me to look at everything that exists in my current directory, which matches what we see here in the graphical display of the same. The next command you probably use quite a bit is cd, lowercase c, lowercase d, which is short for change directory. This allows us to do what I was just talking about a second ago, which is to navigate between directories at the command line as opposed to double-clicking on folders. So if we type cd and then the name of a directory, we can get into that directory. As an aside, know that the name of the current directory is always dot, and the name of the directory one level above where we are now, that is the name of the folder in which our folder is dot dot. Or in which our folder is dot dot. And if you're ever curious about the name of your directory, you can type pwd, which stands for present working directory. We'll take a look at all of these now by heading back to the CS50 IDE. So I'm back in my workspace now, and I'll zoom in again on the terminal so we can take a look at moving around within the IDE. So I'm going to list the contents of my directory again just to reground us in where we are. So if I type ls, which is for list again, I see that I can get to pset0 and pset1. Those are the directories I can get to from here. I know that because the IDE gives me a clue by coloring them blue. Let's say that I want to get into my pset1 directory because I'm working on problem set 1. I can type cd, again, short for change directory, space pset1. And if I hit enter, notice what happens. It doesn't look like a lot has happened, but if you look at the prompt, it now tells me that I'm in ~workspace/pset1. I've navigated into the pset1 folder that was within my workspace. And if I type ls, I see some different stuff here, right? This isn't the same list that I saw before. I've navigated into pset1, and so now when I type ls, I'm getting the context of what can I see from within the pset1 folder. Now I'm going to type Control-L, which just clears the screen. And I'm going to list the contents of the directory again, just so you can see. I just wanted to do that to clear out some of the stuff that you saw down below and to prevent this from going too far down out of range. Now, I said earlier that if I want to navigate to the current directory, I can type cd space dot. Hit enter.
Mm-hmm.
It doesn't do anything, right? I'm changing directories to the current directory. You're not always going to find a need for single dot, but you will occasionally. Let's say that I want to move up one level. I want to get back to my workspace directory. I can't type cd workspace. There's no such file or directory. And the reason for that, if I type ls one more time, is that there's no directory called workspace inside of my pset1 directory. I'm going to clear my screen again with Control L.
You can do CD extras.
Remember what I said earlier, though, that we can navigate back with ... That's the name of the parent directory. So if I type cd space ... and then hit enter, now look at what happened. My command prompt tells me that I'm back in my ~workspace directory. I moved up one level thanks to ... Now, let's say that I'm using an operating system that is Linux-based, but doesn't necessarily tell me where I am. This one happens to tell us that I'm in ~workspace right now, right at the prompt. But I could be completely lost in a mess of folders, and I have no idea where I am and no idea where I want to get back to. There's two things I can do. First of all, I can figure out where I am by typing pwd. That's my present working directory. And if I hit enter, it tells me exactly where I am. Now, /home/Ubuntu is the long.
Let me get my, what is it called? CS50. Dang, what is it? Let me just go here. No, thank you. It was probably on week 0. Previous. My links at transcript, dates, progress, syllabus, what's new, course. I forgot how to get access to the damn. Here we go. View of course dates, communities. Nope. What was it called? CS50.ai. That's the other one. I need the CS50. Dang, what was it? VS Code. I can't remember what it was. Was this? I have to put it on my favorites. Visual Studio Code. Code 50. No, that's not it. Dang, I forgot how to get to it, y'all. That's a ChatGPT one. Damn. I gotta favorite that. GitHub. Let's see. This checks command line program when you check the correctness of your programs. Compare 50. Oh, see, that was the fake one. I'm blanking right now. I am blanking. Damn, that's crazy. So let's go back. We'll go here. Week 0. And then we'll just follow up in the video. The lecture, I mean, because he does tell us how.
Maybe this one. This one will allocate some number of bits or some number of bytes to represent the color of just that there dot, otherwise known as a pixel. You can actually see pixels on your phone or even on your TV or monitor. If you go really close, especially if it's an older monitor, you can see the tiny little squares. Each of those has some number of bits telling the device.
It was not. It was on week 1. Okay. What I'm trying to access, y'all, is the IDE. And I can't remember what exactly that even stands for. IDE. Let me check my notes. Integrated Development Environment. That's what it stands for.
Turns out in programming, you don't necessarily, you have to.
CS50.dev. Dang, why was that so hard for me to find? .dev. I ain't gonna lie, y'all. I probably need to take a nap. It's all good though. We about to power through this. Log in. Yeah, log me in. Hurry up. Hurry up. Okay, there we go. There we go. Let's get this over here. Let's make this like that. Let's make this one like this. Come back over here. See what my boy's talking about. Yeah.
Long way of saying tilde, which is your home directory. But it tells me that I'm in home Ubuntu workspace or tilde/workspace. I'm going to navigate to my pset1 directory again. And I'm going to list the contents. And I see that I have another directory there called extras. So I'm going to cd into extras, and then I'm going to clear my screen. So now I'm pretty far in, right? Like I have what if I want to get back to workspace immediately? There's a couple things I could do. I could type cd ... to move up one level and then another level, but that's kind of annoying. So if I ever want to get back to just my home directory, tilde, I can type cd with nothing after it. cd, enter, and now I'm in tilde. And then if I want to get to workspace, I can just type cd workspace. And that's how you work changing directories within the CS50 IDE or any Linux operating system at the command line. All right, the next one that might come in handy is mkdir, which is short for make a directory. If I need to create a new folder. If you're familiar with a GUI operating system, you might right-click, and then when the context menu pops up, choose new folder. That's probably how you've done it before. But we can also create directories at the command line.
mkdir.
So we're back in the IDE. Folder. I'll zoom in on the terminal.
Oh, there we go.
And list the contents of my directory again, just to get us back, just to give us a frame of reference. Let's say that now I finished working on problem set 0 and problem set 1, so I want to create a new directory to work on for problem set 2. How do I do that? Well, again, I could right-click on the left side there and choose new folder and create a pset2 directory. That would work too. But I can also do it at the command line pretty quickly by typing mkdir space, I typed an N, but space, pset2. If I hit enter, and then I list the contents of my directory again, I see that, look, now I have a pset2 folder, and I can navigate into that using cd and do all the work I need to do for pset2. Incidentally, I'll just pop over here really quickly to the file tree, and you can see that also in the graphical file explorer, we can see that the pset2 directory has also been created there, and I can navigate to it using the GUI as well. The next command that's probably going to come in handy is cp, which is short for copy. Copy, unlike all the other commands we've seen before, takes two arguments: a source, the name of the file that you want to copy, and a destination, where you want to copy the file to.
CP.
It's pretty easy to copy a file, so let's do that. So we're back in the IDE. I'm going to list the contents of my current directory with ls. Now, let's say that I want to make a copy of hello.txt. Again, from the file tree on the left, the graphical interface, I could right-click on hello.txt, make a copy, paste the copy.
Hey,
but I can do it pretty quickly at the command line, too. Let's say I want to copy hello.txt to hi.txt. I can cp space hello.txt. That's my source file, so that's why I'm going to choose that one first. And then I need to name the destination file, hi.txt. I hit enter, and if I list the contents of my directory again, there's hi.txt. I made a copy of it. And in fact, if I went into hi.txt, I could see that it would be an exact duplicate of everything that existed in my hello.txt file.
Code.
So that's how you copy a file. But what if you want to copy an entire directory? So for a second, let's take a look at what's in my pset0 directory. If I cd pset0 and list the contents, I have a directory called sample and a scratch file, scratch.sb2. So that's good to know. So let's clear the screen, and I'm going to go back to my workspace directory for a second.
There we go.
Let's say that now I want to make a copy of my pset0 directory. I can't just say cp pset0 pset3, for instance. Get this weird message, omitting. You get that message? Well, it turns out that when you have a directory that the CP command doesn't really necessarily know what to do with it. We need to explicitly tell Linux, the terminal,
Select all.
I want you to copy the pset0 directory and copy every folder that exists inside of it and every file that exists inside of it. In other words, I need you to recursively dive down into pset0 and make a copy of everything in there. If I want to do that, what I can do is cp-r for recursive, pset0, pset3, hit enter. Now, if I list the contents of my directory, I see there's the pset. And if I cd into pset3 now, and then look, there's sample and scratch.sp2 again. So that's pretty cool. Entire directory and not just a single file. So if you want to copy a directory, just remember to use the -r flag when you're working with the cp command. All right.
What flag? Hold on. Run that back. So cd into folder. Now I'm in the folder one. So make dir. So I can make another folder. We're gonna call this pset2. Boom. So now I have that. So now I want to copy folder. So cp, you said dash space dash r, copy. No, he said folder and pset2. I spelled folder wrong. Oops. Folder. Oh shit. Folder pset2. Because I have the folder. Damn, I can spell it wrong again. Folder pset2. Because I got the folder here with another folder in there called pset2, and I want to copy that. Or maybe I just do folder. No, I just do folder, and I'll copy that to pset3. Let's see how that works. pset3. Because I want the folder to be copied into pset3. Did not work. So let me run it back. Well, let me try this. CP for copy, space dash R for recursive, folder, and then we'll go pset2. Cannot, okay. Let's run it back real quick. Let's run it back.
Do with it. We need to explicitly tell Linux, the terminal, I want you to copy the pset0 directory and copy every folder that exists inside of it. Every file that exists inside of it.
Yeah.
In other words, I need you to recursively dive down into pset0 and make a copy of everything in there. If I want to do that, what I can do is cp-r for recursive, pset0, pset3, hit enter. Now, if I list the contents of my directory, I see there's the pset3 directory that I can work with. And if I cd into pset3 now, and then list the contents, look there.
So let me see what his directory is looking at. So he's cpr pset0. So where is his directory? He zoomed in too much. I need to be able to see the rest. Let me see the other shit. pset0.
Text, I made a copy of it. And in fact, if I went inside of it, the cp command doesn't really necessarily know what to do with it. We need to explicitly tell Linux, the terminal, I want you to copy the pset0 directory and copy every folder that exists inside of it and every file that exists inside of it. In other words, I need you to recursively dive down into pset0 and make a copy of everything in there. If I want to do that, what I can do is cp-r for recursive, pset0, pset3, hit enter. Now, if I list the contents of my directory, I see there's the pset3 directory that
Oh, but I'm in the folder. That's why. Okay, that's why. I believe so. So let's do dot to get back to the dot or pwd workspaces. So I need to go cd dot. There we go. So now I go cp, or I did cd dot to change directory to go to the main one. Now I do cp copy r dash for recursive folder to pset3. No, so we'll try that again. We'll do cp r dash. Oh, dash R. I'm tripping. Dash R folder. To pset3. So I'm trying to copy this folder into this folder. So let's see if this is going to work. CP for copy recursive. So I want to copy this folder and this folder because pset2 is in this folder called folder, and I need to move it to, I need to copy it to pset3. So CP recursive, copy everything in folder to pset3, this folder. That's what I think I'm doing. Let's see if this works. Oh, hey, there we go. Oh, I copied it though, so I didn't move it. Okay, well, at least I did what I was trying to do. But it was dash R. I was doing R dash. Oh man, that's crazy. That was, my syntax was off. But it's all good. So how do I just cut it though? I think RM is for remove. So let me do the clear so y'all can see what I'm doing. Control L. So now I'm in the main one. So let's go. We're going to do CD pset CD space pset3. Boom. Now I'm in pset3. RM for remove folder. Cannot remove folder is a direct. What does it say? Is a directory. Oh. So how do I remove a directory then? I guess I went too fast for them. I guess I went too fast. How to remove a directory in command line. rmdir. Oh, rm for remove, dir for directory, and we want to remove folder. Rmdir failed to remove folder directory. Directory not empty. Oh, so I gotta do recursive. Okay, I got it. So we want to go rmdir remove directory dash r folder recursive. So I want everything in this folder to be removed. Let's see if that works. rmdir help, rmdir invalid option. Try rmdir dash help for more information. rmdir dash recursive. RM command and RM command with the recursive option. Oh, I don't have to do dir. So RM dash R space folder. Descend into directory folder. Yes. Y for yes. Removes regular file. Yes. Remove pset 2. Yes. Remove folder. Yes. Hey, there we go. Okay. I'm cooking with hot grease now, y'all. Remove directory. But I don't have to do rm dir. I just have to do rm. That seemed a little too much, though. I feel like there might have been a shorter way. Okay. Well, anyways, that was not even in the lesson plan, so whatever.
That I can work with. And if I cd into pset 3 now, and then list the contents, look, there's sample and scratch.sp2 again. So that's pretty cool. So that's how you can copy an entire directory and not just a single file. So if you want to copy a directory, just remember to use the -r flag when you're working with the cp command. All right, so I've copied a file, but I've done it by mistake, and now I want to get rid of it. How do I do that? Again, if you're familiar with a GUI interface, you can right-click and just choose delete, and they'll send it to the trash or the recycle bin. But at the command line, we can just type rm for remove, and then the name of the file we want to get rid of. Now, RM is very careful. It makes sure that it does a lot of double checking to make sure that you actually want to delete the file. It doesn't want to make any mistakes because there's no recycle bin here. Once we delete a file, it's gone, and there's really no way to recover it. So we need to be pretty careful, and so RM is going to be really careful for us. So let's go back to the IDE and get rid of that hi.txt file that I created a minute ago with copy. So we're in the IDE, and I'm going to list the contents of my directory again, just to give us some context. And we can see that there's hi.txt, which I created a little while ago. Now I want to get rid of it. How do I do it? Again, just rm. So I can type rm hi.txt and hit enter. And there's RM being really careful for us and making sure we actually want to delete this file. Do you really want to remove regular empty file hi.txt? That's just like an operating system like Windows or Mac that you might be familiar with, popping up that box that says, are you really sure you want to do this? I'm pretty sure I want to do this. So I'm going to type yes, or I could also just type y and hit enter. And if I list the contents of my directory again, hi.txt is gone. Not bad, right? Let's press Control L just to get rid of all this stuff and get us back at the top of the screen. Now, there is a way to short circuit RM so that it doesn't ask us that question. We really know we want to get rid of that file, and we don't even want to be asked the question. How do we do that? Well, we can specify an extra flag, just like we did with CP, where we could add the -r flag to recursively copy into a directory. There's another flag for RM, which is -f, which is to force RM to do exactly what we're telling it to do. So let's say that now I want to get rid of my hello.txt file. I don't want that one either. What can I do? Well, I can rm-f hello.txt. What do you think is going to happen here?
It's just going to delete it.
It's gone. Didn't even ask me the question. And in fact, if I list the contents of my directory again, it's gone. There's no undo here. Hello.txt is gone, and I wasn't even asked if I wanted to delete it. What if I want to get rid of an entire directory?
Timeout. rm-r.
The way you do that.
rm-r, no, -f. I'm trying to get rid of agree. So let's see if this works. Agree. Oh, it worked. So I don't have to go into the folder within the folder to delete it. But to get rid of a directory, I already know. Well, I did it rm-r, or yeah, rm-r for recursive. Yeah. But let's see what he says.
Is very similar to copy. You need to, if you want to delete a directory, you don't just want to delete the directory, you want to delete everything inside of it. And so you use -r to recursively delete a directory. So let's rm-r pset2. I'm not actually working on pset2, so I can get rid of that directory. I hit enter. Do I want to remove the directory pset2? Yes, I do. And if I list the contents of my directory again, it's gone. All right? One more variation on this theme. So I'll clear the screen again to put everything at the top. Hit ls. Now I want to get rid of my pset3 directory, and I really know I want to get rid of my pset3 directory. I can recursively and forcibly remove my pset3 directory. Now, you got to be really careful when you're using rm-rf. As you program more, it'll be something you just do really quickly. And in fact, I do it all the time, but it can lead to some disastrous consequences if you accidentally delete the wrong thing. So I want you to be aware that this is an option available to you, but use it sparingly and use it with caution. I know for a fact I'm not working on my problem set 3 anymore, so I'm going to get rid of all of those files. And I know I don't want to be asked every single time if I want to delete a file. So I'm going to rm-rf pset3. Didn't even ask me if I wanted to get rid of it. I hit ls, pset3 is gone. So that's all the variations that you can use to get rid of files with rm. The last command line argument, that's probably the command line command that's going to be pretty useful for you, is mv, which is short for move. Move is basically equivalent to rename. It moves a file from one location to another, the source to the destination.
Okay.
Let's see where using a move might be handy at the terminal window. So I'm in my pset1 directory, and I've noticed something has gone a little wrong. I was working on my greedy problem, but I accidentally named it Greddy. So when I try and run it through check50, it doesn't really work. I do have a couple of options. We could do what we've done before, which is to make a copy of the file. I could copy
cp Greddy
Greddy.c to greedy.c.
What's going to make a copy?
Hit enter.
Now you're going to have 2 files.
I see that both files are there. And then I could rm to remove
Greddy.c.
Greddy.c. That gets rid of it. So that would work after I confirm that I want to get rid of it. And I effectively have renamed Greddy.c to Greedy.c. I copied it,
Greddy.c,
and then removed the original. But that's a multi-step process, and certainly there's a better way. In fact, there is. So let's hit Control-L just to bring this back up and list the contents of my directory again. So let's say, I made a mistake. I actually really did want to call that file Greddy.c. In one fell swoop, I can type move greedy.c to Greddy.c. Hit enter. And now I didn't have to copy and remove it. I just was able to rename it. One-stop shopping.
MV for move.
Now, there are a lot of other basic command line utilities that you can use at the Linux command line, and we'll be discussing a lot of them in the future in CS50. But for now, just getting your feet wet with working with this terminal environment, these 5 commands should get you pretty far in navigating around and working with files in your IDE or on whatever Linux-based operating system you're using. If you're curious and you want to look ahead a little bit at some of the command line commands we'll be using in the future, here's a list of a couple of the more common ones. I'm Doug Lloyd. This is CS50.
Thanks, Dougie boy. So we did list. Okay, command line utilities. List. Ooh. List equals ls. And then we did cp equals, or copy equals cp remove equals rm lowercase, all lowercase, make directory equals make dir mkdir, and then we did mkdir, and then a recursive delete, or recursive is -r. I don't know what he called the -f. He said shortcut. Yeah, I don't know what that was called. Let's look it up real quick. What is -r command utility? Not R, F. Oops, RF. Oh yeah, that's one too. Command line utility is a tool but specifically RF, to give someone an order. Oh man, y'all got me bent. Let me ask Perplexity, because y'all acting confused. You know what, I'm gonna pull up my pull up my Claude. Damn. Claude, pull this up. Go to my CS50 notes. Boom. Bring that back over here. Slap that in there. Continue chat. Okay, so we're gonna do command line utilities. What does -F and -RF stand for when using command line? Yeah, when using command line. Let me break this down. These command line flags. Force. That's what it stands for. It's to force it. So force equals -F. R stands for recursive, used to apply command to all subsidiaries and their contents. It's like saying to do this to everything inside the folder and all folders within it. Example, copy recursive folder 1, folder 2. These copies the folder and everything in it. RF combines both. Force and recursive. Very powerful and potentially dangerous. Example, R. Remove RF directory with delete directory and everything without asking. Be careful. Think of it like this. F is like boss saying just do it. R is like saying everything inside to R is just do everything. B. Okay, but look, so CP folder. So when you're using the CP, command, I put what I want to copy and then after that I put where I want to copy it to. Is that right? Okay, yes, exactly. The command line works like this. CP source file destination. For example, CP hello.c backup copies hello C into the backup folder. Makes a copy of a file and names it. First word CP, second word this thing, third word to here. Okay, that makes sense. You can also copy multiple files at once. CP file.text and MV. So CP is for copy. Of course, recursive is R is for recursive, F is for force, and then MV equals move. Is it the same for the MV command, which is move, bitch, get out the way? Yes, the MV move command is exactly the same as CP, move source file destination. Okay, those are three different. Okay, move the source file to this destination. Moves LLC into this project folder. My old renames the files also. Move equals move and rename. Okay, so we got those command lines. I ain't gonna lie, that was simple. That's easy to understand. But those loops, I might have to go back and watch those loops videos because I was like, what? My boy Dougie lost me on that one. Oh boy, lost me on that one. Synchronize extractive video screen recordings, read documentation, see example. Oh no, my boy, I don't know what that is. I don't want no parts of that. I don't want no parts of that, my boy. All right, so we might have to go back and do the loop one. This one, it was 19 minutes. But I guess we'll just do command numbers, magic numbers, to see what he's talking about. What is section?
This is CS50 week 1 section on C. So
Damn, there wasn't that on the first. Was there that on the first week? I don't remember seeing all that on the first week. It's just a lecture, right? Lecture and problem set 0. I didn't do problem set 0. Submit starting from scratch. When to do it? Wednesday, December 31st. I got plenty of time. I'll do it tomorrow. Here's Dave's example of lecture review. Oh yeah, see, look, all these bunk ass games. How do I play this shit? I guess I can't play it. Let me stop playing flag me. They're gonna flag me. YouTube gonna flag me for stealing the NFL song, man. Don't do that. Look, this is the game I was working on right here, man. I was having some troubles. So I got my nigga to move, but he glitching. Like, why he glitching like that? He's supposed to just run smooth. And then when he runs smooth, he runs in the air. And then when he runs that way, he just be gone. So, and I haven't got a jump feature in this, but I don't think I can get him to jump because they don't have the right. I think I'm doing too much with this basic animation. I think if I have him stay still instead of charging his chakra, then he can move more smoothly because it's adding too much. Let me see. Yeah. Right here. Move right arrow. Repeat until not right arrow pressed. Point direction 90. Switch to costume tile. Wait. What if I do .01? See how that looks. Stop. Oh, that's kind of better. Is another one? Oh, there's another one. Here we go. .01. Stop it. Make this full screen real quick. Hey, I fixed it just like that. Look at my boy running. But how do I get him to run on the ground though? Why he get up like that? I know why. It's because the sprite is doing that. So I need him to point in direction, and I need him to set X to change which one's Y. Set Y to 18. Yeah, exactly. So let's do that. Nope. Oh, that is 18 for him though. So I need to be like what? 12? No, I need to be like 5. Almost. Well, see, now he down there. Okay, but then up here, when green flag clicked, go to the if then I need to copy this, duplicate. Oh no, not all of that. No. Go back. Did I duplicate it? Damn, I can't see this shit. Where's the undo? Control Z. Control Z. There we go. I just need this block right here. What the fuck? I just need you, my boy. You know what? Fuck it. Keep that there. I need this to go right there. Now let's try. He still goes back. Repeat until that's confusing. Else. Oh, else. Right here. I think that's where I'll put it. So delete block. Go to this block. Okay. No, he still goes back down there. It's because those sprites. So this is why he's doing it. Costumes. So this one, see, the running costumes are cut higher than the chart. See, look, up here he's right there. So can I move that down? Is that a thing? What's this do? Select. Because, yeah, that's what it is. Let me see. Let's see. Put the folder right there. So move them down right here. Move this one down right here. Oh, shit. Move them down right here. Move them down right. Oh, convert to vector. Down right here. Move him down. Convert to vector. Move him down right here. Move him down. Convert to vector. Move him down right here. Convert to vector. Move him down right here. Now let's see how that hits. Okay, stop. I can get rid of this. Delete block. Put that back where it was. Redo that. Run. Hey, oh, but now I gotta go. I gotta move. Where's it at? So I gotta delete this block. Refresh. Hey. I'm a genius, y'all. But I gotta fix this. And it's still kind of glitching on that last part. But he running. I see a nigga running. Let me zoom in. Where's this nigga running, y'all? Damn, how do I? Hey, he running for real. How do I get him to jump, though? So I gotta get him to jump. And I gotta get him to Rasengan some shit. And then I gotta add some music. And then I gotta get it to where when he crosses, Oh, what? Oh, that's interesting. When the boundaries come into play. So how do I get them to stop that last part? So let's zoom back out. Something with this. When right arrow key pressed, repeat until not right arrow key pressed. Point in direction 90. Switch costumes. Da 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 da. And that's repeat until. And I need something that just doesn't. Because what it's doing is each after it goes through each costume. So boom, the running process looks like this: 1, 2, 3, 4, 5, 6. After it does those 6, it goes to this one automatically, which is why. Oh, it just, I don't know. It just does it sometimes. It only does it when he gets past this mark. Oh, no, it's doing it. I don't get it. It's not doing it consistently, which is confusing. But I'm about to make that my game right there. That's it. No, but pretty much I need to delete this. I'll keep it, but I'll copy this, duplicate it, boom, bring it over here. Make this negative 90. So he goes the other way. Same thing, 0.01. And then I need to delete this. Delete block. How do I delete everything? Okay, stop that. Reset it. Oh, shit. Now my nigga confused. Oh, left. My bad. I need to change this to left arrow. Change this to left arrow. Reset it. Hey, we running. Maybe that's too fast though. Maybe I need to wait. I mean, it's cool. I'm not gonna fuck with it. It's moving, so I'll just make it move. But and then this two right here, I can probably fix that now I think about it. So his foot is right here. Move him up a little. Oh, let me make sure. So it's like right on the gray. Damn, I don't. Right on the gray. Right there. Yeah. Now he going up a little bit. So how about this? We'll bring, oh shit. There we go. There we go. Fine tune that thing. It really looked like he running too though. But that's the last thing is how I get that little glitch out the way. That's kind of hard though. I ain't gonna lie, y'all. But how do I get that glitch out the way? I needed to, or maybe I don't have this last weight here. I don't have the last weight. That's probably what it is. Oh, I'm fucking genius. Okay, but now let's go 0.5. I think that, or 0.05. I feel like that animation is a little too fast. 0.05. Oh, now you want to do it again. Ah, damn it. So 0.01. Let's just stick with that. We'll stick with 0.01. 0.01. Stop. He running, but I don't like it looks too fast. Like his feet move too fast. But I mean, he's running. Shit, I'm not gonna complain. He runs left and right, and when I stop, the nigga charges up. Like a game. You feel me? He runs on the ground, charges, stop, charge. So now I gotta get the other ones in here to make them jump. Cause I got these. Let's see where they at. Sprites. Right here. I had to download these right here. I had to cut them up individually. Well, I ain't gonna lie. I had a. Ooh, I'm trying to get that Rasengan going though. Make the nigga sleep. Oh man. So I need tile. Oh shit. I need tiles 9, 10, 11. Maybe I'll just do 4 and 5. 4, 5. Let's see. See if we can add that real quick. So we want when. Let's just copy this. Let's just use the same framework. So we'll go with when A pressed until we gotta make the new costumes. So we'll upload costumes. We'll go to where's this at? Downloads, easy GIF. So we'll go here, upload, downloads, easy GIF. And we want 4, 5. I feel like I should do like 10, 4, and 5. We'll do 10, 4, and 5. 10, 4, 5. Open. Okay. 10. Oh, fuck. Don't I already have 10 in there? Oh, tile 10. tile 10, 4 and 5. So let's see. So 1. So we'll put this up here. 10, 4, 5. So we'll make that the A button. We gotta make them on this point right here. So we'll turn them into a vector. Bring them down right here. Turn it to a vector. That looks pretty good. Might have to move them up a little bit. This one. That looks pretty good. I think. That looks good. So come back here to the code. And then we'll hit. We need to point in whatever direction. We don't really need a direction. So delete block. Switch the costume. Tile 10, 4, 5. Tile 10. Tile 4. Tile 5. And we don't need them to move. So we can delete that. Delete the move. Delete the move. Delete the move. Delete the weight. Delete the costume. Delete the move. Delete. 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 So now I run. Oh shit. Oh shit. Run. Oh, that's way too fast. 0.0. Let's do 0.1. That's the attack. Bitch is kind of fast though. 0.5 maybe. That's too much. 0.1. That's better. It's kind of let me see. Put another weight on there at the end and see what happens. 0.05. I mean, it's not pretty. Oh, that's better. That's better. So I'm running. Okay, so we got the running. We got the punching. I mean, realistically, I should be adding enemies and shit, but I gotta get some enemy sprites, and they gotta go back and forth. And when he gets contacted with the other one, I gotta make it so it, yeah. Should I add a jump sprite? Yeah, I might as well do a jump while I'm here. So let's see, which one can I use for jump? Do 24. What is he doing in this one? Well, this one he gets hit. I don't like that. $24. 24. 15. 24. 14. 15, 24, 14. 15, 24, 14. 15, 24, 14. Upload 15, 24, 14. Open. So we'll go 15, 24, 14. So when he jumps, it's like that. So we'll convert to vector. Make sure it's on the same tile right there. Convert to vector. Move them down. Right about there. Convert to vector. Actually, this one we would actually have to be up. So we'll make it like right there. Convert to vector. Right there. Is that a high enough jump? I don't know. That's like the charge up. That's the jump. Moving forward a little bit. Moving forward a little bit. Let's keep his head in the same area. That's what we want, his head in the same area. So move his head over here. Move his head over here. Boom. So then we'll come over here and we'll duplicate this down here. Change this to the up arrow. Up. Up. We don't need this. We can delete that block. Switch to costume 14, tile 14. What did I say? I said 15, 24, 14. 15, 15, 24, 14, and then back down to 24 to 15. Then I'll take out the move 3 steps. Move 3 steps. Move 3 steps. That little baby ass jump. Okay, so let's make this a little bit better. And let's do this to 0.1, 0.1, 0.1, 0.1. Hey, now we jumping. Hadouken, Hadouken. The jump a little glitchy, I ain't gonna lie. I mean, well, that's fuck it, man. You know what I'm saying? Can I make it glide? I think I should make it glide, huh? Is it that glide one? Or is it that? Motion. Glide. Is that a thing? Can I make it glide? But it's not going to switch the damn. No, because I can't make it. I can't make it to stay where it's at. So I think I just did the best way, to be honest. I mean, I could make it more like animated, but that's good, man. That's good. That's my first game. I ain't trying to get into detail. You know what I'm saying? I got Hadouken, Hadouken, Hadouken. Jump, jump. Man, I'm pretty dope if I say so myself, man. That's better than the damn Harvard game they had. This is way more interesting. I need some enemies though. Man, that's A1. I think I should submit that as is. Let me see. Submit starting from scratch. What's the assignment though? Your project must use at least 2 sprites. Did that. At least one of them, which must not be a cat. I did that. Your project must have at least 3 scripts. 1, 2, 3, 4, 5 scripts right there. Not necessarily 3 per sprite. Your project must use at least 1 conditional, at least 1 loop, and at least 1 variable. Damn, am I using a conditional? I got a loop, a variable. Damn, oh fuck. I think I'm using it. I think I'm using a conditional. No, I'm using a conditional if, loop, repeat until, forever, variable. That's the move. So yeah, I'm check. Your project must use at least 1 custom block that you have made yourself via make a block. Which I didn't do that though. Okay. Your project should be more complex than most of the demonstrated in lecture, many of which through instructive were quite short, but can be less complex than Oscar time and Ivy's hardest game. So I got to make a block. I don't know how I would make a block. Let's see. Control F, scratch. How would I make a block though? My blocks, make a block. Block name. Let's call it shadow clone. Shadow clone block. I don't know where I'm going with this, but we're just going to roll with it. Run without screen refresh. Add an input. Add an input. Number or text. I don't know. No, I gotta figure out. I don't know how to incorporate this. I'm about to go back and watch the lecture because I just don't know how to incorporate that into my thing.
What color to use. In particular, these devices typically use 3 numbers in total. Work in a language called C. It's an older language, but it remains one of the most popular. See a few different regions of the screen. One, we have this palette of puzzle pieces at left. The blue ones relate to motion. The purple ones relate to looks. The pink ones relate to sound and so forth. So the color of the blocks just roughly categorizes what that block's purpose in life is. We're going to be able to use those puzzle pieces by dragging and dropping them from left to right. In the right here, in the middle of the screen, is where I'm going to write my actual programs. This is where I'll drag and drop these puzzle pieces, lock them together, and actually write my code. What am I going to be coding? Well, I'm going to be controlling one or more sprites. Much
Time
like
out. I'm gonna make the cat. I'm gonna make the cat the evil nigga. Oh no. Give me this. Where's this cat at? Where the cat at, man? I'm about to be blasting this cat. Here he is. Cat. Oh, cat ass. Damn, it's a big ass cat. You gotta calm down, my boy. Downsize this nigga. Okay, that's cool, but it's... Oh, they got the whole thing. No, let me downsize this whole nigga. There you go. Make him a little bit bigger. Actually, should I make him bigger or smaller? We'll make him that size. Same thing with this. Wish there was a... We'll make his ear go to that block. Oh, it did. Oh, jolly ass nigga. All right. So we're gonna come back to the code. Where my shit at? Oh, he ain't got no sprite. So we're gonna make him. We're gonna make this nigga move. He gonna glide. So we're gonna have him start set to when green flag click, take your bitch ass over here. And then glide your bitch ass this way. Yeah, that sounds about right. When green flag clicked, we want your ass over yonder. And we want your ass facing this way, my boy. Oh, don't do that. Oh, wait, I gotta do it like this. Boom. $90. Come on. And we want you to be 200. Perfect, my friend. Perfect. We want you to glide to so that's 200. Want you to glide to 0 when green flag clicks. Oh no. Negative 90 or no, negative or 41. So where is this? Negative 211. So we want you to glide to X negative 211. Negative 211. So let's run that back. Start over. Oh no. We want you to, when green flag clicked, you need to start over here at 204. Whoa, slow down. 0.05. Oh, well, no, wait. We'll do 3 seconds. And then I come through and blast your ass. Bye, y'all. So, how do I do that? Events. When 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 the sprite is clicked, when loudness, motion. Damn. So I need something that says when the sprite gets you. I don't know how to do the variables in the blocks yet. Sensing. Okay. Touching color, change distance to pointer. Key space press, mouse down, set draggable. Backdrop, current year. Events. If touching tile, actually, I need to be. Why is it just tile 21? If touching to child 21, then delete this clone? No. Oh, right here. No, that's not it. That's gonna be a little bit trickier. You know what? I think it's time for a break though, y'all. So let me put y'all on some of these smooth tunes for y'all, man. I'm gonna put on some smooth tunes for y'all. Yeah. You tuned in to Coding Radio, where we are gonna code our way into the future. All right. Okay, y'all. We're gonna get this coding popping. We got this ring light commercial. Oh, library. Skip that. Suno library. Come on, library. Don't fail me now. Young brother need to take a break. Seriously. Suno down, y'all. Dang, every time I try to do this, it be hating on me, low key. Come on, Suno. Wow. Damn it, that's crazy. Well, we're just gonna come over here and y'all just gonna have to chill out with the matrix code until I get back. I'll be back. Okay, y'all. We are back. Oh, now I want to pop up. Be right back.
riddle of man, creation of God. Science extended the life of me. How could you like this? The rise of a hero, the fall of a god, defining the complexities of man. Usher in the new age, awful handshakes, rock on with the fake personalities. Listen to my words, my wise words. A valley in the desert, lakes in outer space, in a world where time can stand still. Every time I see you, I see you, I see inside myself, understanding the complex definition of the mermaid, definition of sin, dreaming of palm trees in the sea. Every time I see you,
All right, I'm back, y'all.
heaven's a place of greenery. It is fulfilled. It is
Let's see what these right here.
In the world of games, if familiar, a sprite is like a character that you might see on the screen. The default character in the world of Scratch is, in fact, a cat that looks like this. And if, in this case, I have just one cat, I can then make that cat do things in his own little world at top right by making the cat move up, down, left, right, spinning around, or doing other things as well. But if you want to introduce a dog or a bird or any number of other custom characters, you just add more sprites, and they get their own place in that same world. As for how to think about movement in this world, it's actually pretty familiar, even though it gets a little numeric for a moment. If Scratch at the moment is in the middle of the screen, the cat is at 0, 0. If you think about x, y coordinates or latitude, longitude, if you move the cat all the way up, this would still be x equals 0, but it would be y 180. What's the 180? 180 pixels vertically, or dots on the screen. This is negative 180 pixels on the screen at the bottom. By contrast, if you go left and right, your x value might change, negative 240, but y is 0, or positive 240, and y is 0 as well. But most of the time, you won't need to know or care about what the pixel coordinates of the cat are. All you're generally going to care about, as the programmer most likely, is do you want the cat to go relatively up, down, left, or right? And let MIT figure out the mathematics of moving this thing around in most cases. All right. So let's go ahead and introduce the first of these programs by doing something quite simple, as we did in C there, but a little more simply by writing code as follows. I'm going to go back to scratch.mit.edu. I've already clicked, per before, the Create button. And if I click on the yellow category of blocks here at left, and I'll zoom in, we'll see a whole bunch of yellow puzzle pieces. And probably the most common one you will use to write code in Scratch for just this first week is literally when green flag clicked. Why? Well, if we go back over to the cat's world at top right, notice that above the cat's rectangular world, there's not only a green flag for starting, there's a red stop sign for stopping as well. So let's do this. Let me go ahead and click and drag when green flag clicked anywhere into the middle and let go. And now I'm going to go to looks, and it looks like there's a whole bunch of purple puzzle pieces here. I'm going to choose something simple like say hello, drag it, and notice if I get just close enough, it's going to want to magnetically snap together. So I'll just do that, and it does its thing. The fact that there's this white oval with text means that is an input to this say puzzle piece. I can literally then change what the input is if I want to more conventionally say hello, comma, world, which in fact, according to lore, was the very first program written in C, and nowadays in most every language, including in Brian Kernighan's book. So hello world is generally the first program that most any programmer first writes. So that's it as programs go. Let me go ahead and zoom out here. Let me go over to the right and click the green flag, and somewhat excitingly, maybe underwhelmingly, we've now written a program that quite simply says hello world on the screen. Now let's make this a little more technical for just a moment. What is this here puzzle piece, as I keep calling it? It's actually a similar, it's an incarnation of one of the ideas from our pseudocode before. What did we call those actions and verbs last time in my pseudocode?
Variables.
Functions, that's right. So
Oops.
these purple puzzle pieces here are indeed functions, and some functions, as we can see, take inputs like hello, comma, world. After all, how does Scratch know what to say? You have to provide the cat with input, which is to say functions can indeed take inputs like this. In this case, one input, but we'll see opportunities for passing in more input as well. What the cat is doing, though, visually on the screen here at top right, is what's generally called a side effect. Sometimes when you call a function, it does something visually. And in this case, you're seeing literally a cartoon speech bubble, hello world. That is the side effect of this function. So if we now want to map this to our world of inputs and outputs and see where this side effect is, this is the paradigm I proposed at the start of class that is computer science in a nutshell and will be the framework we use literally throughout the class, no matter how the languages in particular evolve. So what's the input to this particular program? Well, this white oval, hello world, is my input. The algorithm, step-by-step instructions for solving some problem, is implemented in code, this language called Scratch, by way of this purple puzzle piece. And the output of that function, given this input, is the side effect whereby the cat indeed says, hello world visually on the screen in that speech bubble. So the exact same paradigm with which we began today governs how exactly this cat here works. Well, let's actually go back to this program and make it a little more interesting than that. Let me go ahead and click the red stop sign. And let me actually use a different type of puzzle piece, another function that does something a little different. First, I'm going to get rid of the say block. So I'm going to not only pull it away, I'm going to drag it over anywhere it left and just let go, and it will delete itself automatically. Or I could right-click or control-click, and from a little menu, I could also explicitly say delete. And what I'm going to do now is under sensing, which is a light blue shade of puzzle piece. There's a whole bunch here, but I'm going to focus on this one. Ask something and wait. And the default text is what's your name, and that's fine. But because it's a white oval, that input can be manually changed by me if I wanted to change the question. I'm going to drag it over here. It's going to magnetically snap together. And I'm OK with that question. But what do I want to say with the answer? Well, let's go ahead and do this. I could go to looks again. I could grab another say block, let it snap in. And I could say something like, hello, comma, David. But this is going to be the first of many bugs that I make, intentionally or otherwise. Let me click the green flag. Scratch is now, just like in a web browser, prompting me for some input here. So let me go ahead and type in my name, David, enter, and voila, like it works. Hello, David. I'm kind of cheating, though, right? Because if I zoom out, stop, and play again, let me type in like Yulia's name here, enter, and it still says hello, comma, David. So that didn't really implement the idea that I wanted. All right, so how can I fix this? Well, it seems that this time I want more than a side effect. I want to use the value that the human types in. And for this, we need another feature of functions, which is that not only can they sometimes have side effects, something visually happens, some functions can hand you back a value, a so-called return value that will allow you to actually reuse whatever the human typed in. So a return value is something that gets virtually handed back to you, and you can store it in something called a variable, like X, Y, and Z in mathematics, and you can generally reuse it one or more times. So let me actually draw our attention then to, at left, not only the blue puzzle piece, ask what's your name and wait, but notice that there's a special puzzle piece below it, this blue oval called answer, and that represents what a computer scientist would call a return value. So MIT has kind of bundled it together side by side to make clear that one of those pieces relates to the other. What it means is that I can do this. I can drag this oval and use this oval as the input to the say function. Now notice it's not the same size, but it is the right shape, so that's okay. Scratch will sort of grow or shrink things to fit properly. But this too isn't quite right. Let me go ahead and do this. Let me go ahead and stop that, click the green flag. I'll type in my name again, D-A-V-I-D, enter. And it's just kind of like weird or rude. Like I wanted a hello at least, and it just said David on the screen. Okay, so I can fix that. Let me stop with the red stop sign. Let me just separate these temporarily, and I can leave it in the middle there, but they have no logical connection temporarily. Let me go back up to looks. Let me grab a say block, a second one, And let me go ahead and say, just to be grammatical, like hello, comma, space, and then I'll reconnect this here. So at the moment, it looks like what I want. I want a hello, comma, and then the return value printed out based on whatever the human typed in. So let me zoom out. Let me click the green flag. Again, what's your name? DAVID, and watch the cat side effect. Enter. Still not greeting me properly. There's no hello. And if in case it was too fast, let's do it again. Green flag, DAVID, enter. It rudely just says my name, which is weird. What's the bug here, though? It's a little more subtle.
It needs to be a if-then statement.
Yeah, it's just too quickly going over the say command or the say function in this case. My Mac, your PC, your phone is just so darn fast. Both are happening, but too fast for my human eyes to even notice. So we can solve this in a number of ways. I could actually use a different puzzle piece altogether. In fact, MIT kind of anticipated this. Notice the first puzzle piece in purple is say hello for a specific number of seconds. And you can specify not just the message, but the number of seconds, ergo 2 inputs, otherwise now known as arguments to a function. An input to a function is just an argument now. And that would be a fix here. I could maybe a little more explicitly do this. I could go under events, scroll down a little bit, and under control in orange, I could grab a wait block, and I could kind of insert it in the middle. And this might actually help. So I could click on the green flag, DAVID, enter, hello, David, and I could change the timing to be a little more natural. But what if I want the cat to just say, hello, comma, David, all in one breath, so to speak? Well, for that, I'm going to need to use a slightly different technique as follows. Let me go ahead and get rid of the wait. Let me get rid of the second say block and stop the cat with the stop sign. Let me go under operators here, and let me somewhat cleverly grab this, a join block at the bottom. By default, it's using apple and banana as placeholders, but those are white ovals, so I can change those. Let me drag this over the white oval for the say function and let go, and it will snap to fill. Let me go ahead here and type hello, comma, space instead of apple. And what should I do instead of banana? Yeah, so the answer return value, the return value. So let me go under sensing again. Let me just drag another copy of it. And you can use these again and again and again. They don't disappear. I want to drag answer over banana so that the second input to join is actually, if you will, the output of the ask block, like that. And it snaps to fit. So now if I go ahead and click the green flag once more, DAVID, enter, now we have the sort of behavior.
Okay. So that means that, where my scratch at? I think I should, the operators. So I need this. If touching tile 1, oh shoot. If touching tile 1 and what? And maybe not. Maybe I don't need that. Hadouken. Why am I Hadouken doing that? If touching tile 21. Oh. When green flag click, go to 24, glide. We'll do a slower 5 seconds. Okay. If touching tile 21 and an A arrow pressed, delete this clone. Right, that should be it. Oh, Oh, come on, that should work. If touching tile 21. Oh, why is it not working? Costumes. I rename this. Can't rename it. Copy group flippers on delete. It should be working. When green flag click, go to this. Da, 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 da. If touching tile 21 and A key pressed, then delete this clone. Or let's ask ChatGPT or Claude. Okay, I added another, so y'all can see what I'm doing. I added another sprite, and I want to make it the enemy in the game. The sprite is the cat. When the cat touches Naruto while he is pressing A, I want him to disappear or be defeated. Yeah. I can help you set this combat mechanic. You need a script on the scat practice check. If it's touching Naruto, press and if A key is pressed. If touching Naruto and A key pressed, then hide end to end. Well, where the fuck is the hide at? Where is hide? Looks. I want to make Game is over. In order to get points, you must defeat the cat. When green, okay. First, go to variables. Go to make a variable. Name it score. Variables. Make a variable. Name it score. When green flag click sets. Okay. Show forever. Oh, I see it. Show if. Okay, so events versus a if if okay, it's like this forever. I need this to come over here. If touching, then hide. If touching Naruto and capers, then hide. Change. It's not disappearing though. Score by 1. Wait. Okay. If score equals 9, then show or if score less than 9. Okay. If score then show it's not working when A is being pressed and the cat touches Naruto. Okay, if touching Naruto and keywords using hide, change score 1, wait 1 second. Okay. Okay, well. Okay, if touching Naruto and A pressed and hide, change score by 1. If touching Naruto and P pressed hide, change score by 1. Wait 1 second. If score less than 9, then show. Go to X, duplicate. Oh no. Just need this piece right here. Oh no. How do I detach that? Show. Go to won't. Else. Oh, I gotta do else. So oh shit. If else then delete block. If else then else say game over, you win. Stop all. Still not working, my friend. So let's go to the snipping tool. Window logos, key, shift S. S. Motherfucker. Fuck up the way. So for Child 21, but this appears to be a costume name, not the sprite name. You need to check if it's touching Naruto sprite. Let's fix this one, please. How look at the bottom right where my sprites are. It has the cat sprite and tile 1 sprite, which has all the other costumes in it for Naruto. I don't know how to rename a sprite, but does that give you more context? On my panel, click the text box. Oh shit, Naruto. Forever. So wait, am I making a whole another script? Okay, come on. Yes, I have. Yes, I want to make it so the cat moves from right to left. And when it responds, it moves from, yeah. When green flag clicks, set score to 0. Okay. Forever. Forever if high. Change score by 1. Change score by 1. Wait 1 second. If score less than 9, then show. Go to X204 41. Respawn on right side. Else, saying game over, you win. Stop all. And then cat movement. If showing, if showing wait, what? If showing where the fuck is that at? Where's the showing boolean? Okay. I don't see no showing. Yeah, I don't see it showing. Damn, something happened. All right, y'all. If touching top to one person hide, let me put this next to each other because I just want to make sure I got this right. And then this one we want scratch. Make sure this is lining up. If touching tile 21 Naruto and A key press, then hide. Change score by 1. Wait 1 second. If score less than 9, then show. Go to respawn on right side. Oh, wait. Else, oh no, we're right here. If touching hide, change score 1. Wait 1 second. If score less than 9, go here, show. Else, say game over, you win, stop all, and end. Where is end at? Stop all, end. Something's not adding up here, y'all. I'm getting confused as a motherfucker. Hell, say game over, you win, stop all. Let me see something. I don't even know if this will work. Check my settings again. See if it will work. Check my screenshot again. Let me know if I have the right setup because I don't know where there is an end block at. Can you look at my screenshot again? Period. I don't know where a end block is. Period. I'm trying to make sure I have the code correct, but I'm still getting the same problem. When I press A, the mouse is still, the cat is still there. Okay, my boy. Because this is getting out of hand. Man, okay. Control S. Oh my goodness. I'm right there, y'all. I know I'm just missing one step or something. I don't want to keep pasting in these pictures because it's going to say that I'm done. But it's going to say I got too many images in the chat. Let's try this structure using the blocks. I can see it in your screenshot. When green flag clicked. Okay, let's do it like this. So let's do it like that. When green flag clicked. Could y'all hear me? Let me turn this off. Let me make sure y'all can still hear me. Check, 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 check. Okay, yeah, y'all can hear me. Wait, can y'all? Am I still live? Check, check, check.
Check, check, check.
Okay. Name this Naruto. Okay. When green flag click, set score to 0. Show. So we go to show. Let me just duplicate show. Damn, I just seen it. Where to go? Show. Forever. Go to da-da-da, glide to da-da-da-da. If key A pressed, then if key A pressed, then if touching Naruto, then hide. Boom. Change score by 1. And then. Oh shit, that was in the right one. When green flag click, touching Naruto and key. Oh, it worked. Oh, I'm blasting his ass. Let me see. Oh, no, it didn't work. That was some bullshit. Motherfucker. Okay. Set score to 0. Forever. Oh my goodness, this is getting complicated. Set score to 0 forever. If touching Naruto, if touching Naruto and A key pressed, then hide. Okay, we're gonna hide. Then hide. Change score by 1. Hide. Wait 1 second. Wait 1 second. If score is less than 9, go to else. It's not working, Claude. Okay, let me look at this myself. When green flag click, set score to 0. Okay, forever. Oh, I don't need a forever loop. What? If score. Oh, yeah. You bitch. You just worked. Ah. Nope. Come on, man. It's not making sense. I think I think there's a problem with the respawn. Forever. If touching Naruto, touching Naruto and AQ press, then hide. Hide. Change score by 1. Wait 1 second. It's score less than 9, then go to 4, 41. Show. If for the movement part, is that a separate script? Now, when I press the green flag, the cat just comes out saying game over, you win. When green flag clicked, set score to 0. Show. Show forever. If hide, change score by 1, wait 1 seconds. If score less than, show. Else, say game over, you win. Stop all. Now the script is just stopping all when I press the green flag. If touching Naruto to an A, correct fresh, hide, change score by 1. Let's do 3 seconds. If score if score equals 9, then say game over. Stop all. Else, oh shit, now we cooking. Bing. Bing. What the? Bing. Game over, you win. Game over, you win. Oh, where the cat at, cuz? Where the cat at? Okay, look, we'll do it like this. Put Amon in here. He over here, Superman. Whose man's is this? Let's do 50. You know what? We'll just keep him right here. Oh shit. 50. Okay. Right. Events. If score equals 9. When green flag clicked, hide. Yep. What I need you to do is hide. If score equals 9, show, say, game over. Game over. Over. You. Damn, that shit's so small. I can't read that shit. Win. Bam. What? Bam. 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 What the fuck? Bam. 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 Okay, well, that didn't work. So we'll do control. So we'll do if bam. Bam. What the fuck? Why am I nigga popping out? Pop out. Oh, I know why. I know why. Okay. Leave block. this right here. Say game over. Wait. Make this thing to wait. Where is the wait? Where is the way? There it is. If wait 3 seconds. Bam. 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 Dang, my back hurt. I need a massage. Oh my gosh. Oh shit. The cat's a little glitchy. The cat is a little glitchy. What? Where he pop out? Damn. If oh, if score equals 1, then show. Bitch. I might need another wait. Probably need another wait. If score equals 1, then show. Wait 1 second. Wait 1 second. Say game over. You. Come on, man. That's a simple ass function. If score equals 1, then wait 1 second. Come on, man. I mean, the game works, but it's a few glitches that need to work out. And honestly, I ain't got the time. I mean, I really do got the time, but I don't even got the patience right now. So we are going to go back to this one.
Hit technical support headaches in the very beginning of the term, so we suggest you do that later in the term once you're already comfortable with this cloud-based environment here. And here it is. This is what programming shall look like, whether we're using C now. Shall be a char, not an int, not a string, a single char. All right, now what do I want to do? I can ask a question. If C equals lowercase y, then go ahead and print out, just so we see something on the screen, agreed period \n, as though they agreed to the terms and conditions. Else, if C equals lowercase n, go ahead and print out, for instance, not agreed, just so we see something on the screen. So let me hide my terminal window and focus on the code. There's a couple of details here that are a little interesting. So one, what did I do on line 7 and 11 that is not consistent with what I've done before?
Equals.
Subtle. So I'm using apostrophes or single quotes now instead of double quotes. Why? It's a C thing. When you're using strings, you use double quotes. When you use single chars, you use single quotes. So the argument to get char, that's still a string. It's a whole sentence that I'm passing in. So that is just like get int, just like get string. But when I get the answer back, the return value, and put it in this variable, and I want to check what is that one char, I have to surround the char I'm comparing against in single quotes or apostrophes, both for the y and for the n. So this program's not super well designed because it's not going to handle uppercase. It's not going to handle weird inputs very well. But let me open my terminal window, make agree, enter. The code compiles OK, /agree. Do I agree? Let's try it. Y for yes. OK. Let's try it again. /agree. N for no. Not agreed. Let's do it one more time. Let's very enthusiastically say yes in all caps. And it just kind of ignores me. But why? Well, this is a feature of CS50's getChar function. If you tell us you want to get a char, we're not going to tolerate a whole string of text from the user. We're going to prompt them again and again and again until they give us just one char. So yes is 3 times too long. So let's actually just do a single capital Y and see what happens. Return. The program ignores me altogether. So all right, this is kind of a poorly designed program. It's a little annoying that we'll just ignore humans, even if they type in Y or N that just happens to be uppercase. So let's improve this. Let me go ahead and add a couple more conditions. Else if C equals uppercase Y, then go ahead and print out agreed, same as before. And then down here, else if C equals capital N, then let's go ahead and print out again, not agreed. So this is now more correct. It's still going to ignore bogus input. That makes no sense if it's just like the word, if it's a different letter altogether. But this to code, while more correct in some sense, is still poorly designed. Even if you've never programmed before, what rubs you the wrong way about this code now? Be critical. Yeah. Yeah, it'd be nice to just merge the lowercase and the uppercase y together. The same thing for the lowercase and the uppercase n. Why? If only because like literally lines 9 and 12 are identical. Lines 17 and 21 are identical. And while not a huge deal, you know, if I go in and I change this sentence, odds are over the course of my lifetime programming, I'm going to forget to change this one, even though I changed this one. Or I'm going to forget to change this one and this one. So you don't want the code to get out of sync potentially. And you certainly don't want to repeat yourself. So don't repeat yourself is a tenet of programming too. If you can avoid that by somehow factoring out some commonality, you should do so, similar in spirit to math when you factor out variables or the like. So let me tighten this up, so to speak. Let me get rid of what we just did so that it's a little shorter as before. And let me express myself with two conditions using the following syntax. I want to check if C equals lowercase y or C equals uppercase y. So you can actually use what's called a logical operator, two vertical bars, which means or, and we can do this down here, or C equals capital N. So same exact functionality, but to your point, we've now eliminated what, like another one, it was like what, 4, it's like 8 lines of code now are gone, which is 8 fewer lines that I might screw up in this program, less opportunity for mistakes or bugs, probably a good thing. So now if I run this, let me open my terminal window. Let me run make agree, enter, /agree, enter. Do I agree, capital Y? Now it seems to be handling both of those situations. So just a little tighter. As an aside, we won't use it here, but if you want to say and, which would be nonsensical, it, a little confusingly, is 2 ampersands, means a logical and, whereby the left thing has to be true and the right thing has to be true. So it's 2 Boolean expressions at once. This one makes no logical sense, though, because a character cannot be simultaneously lowercase and uppercase. It's got to be one or the other. So 2 vertical bars is logically correct. That represents our notion here of or.
Okay, so damn. So we got, what is that called? Is that a variable? Gotta go back and look at that.
Or. Question? No? Yeah. You could not write or. So I'm saying or just because that's a little more normal, but this is incorrect. However, sneak preview, in the language of Python, you actually will literally say or among other things, which gets a little more user-friendly. Other questions on this here? Searching? Yes, in back. Is there an easier way to handle case sensitivity? Yes, and we'll show you that next week, in fact. So we can combine this code to be even tighter. All right, let's do one final set of examples before taking a cookie break, if we could. But let's go ahead and close agree.c here. Let me open my terminal window, and let's go ahead and implement a sort of virtual cat as we did last week. I'm going to code up a file called cat.c, and I'm going to implement this in a few different ways, the first of them pretty foolish. So here, I'm...
Time out, y'all. It's getting tough out here, y'all. You really out here. Check. All right.
I'm going to include standard io.h, no need for CS50 just yet. Int main void. Inside of these curly braces, let's go ahead and do printf meow to get the cat to meow. And then to save time, I'm going to copy paste that 2 more times. So this cat shall meow 3 times in total. All right, I'm going to go ahead and make the cat, so to speak. All good. /cat, enter, and it meows 3 times, just like our scratch cat last time. I'll stipulate this is correct. This is a really well implemented cat, correctness-wise, but why is it bad design intuitively, just like last week?
2 extra lines of code.
Sorry? I keep repeating the code. I mean, I literally copied and pasted, which is sort of your first obvious sign. I'm probably doing something wrong if I'm copying and pasting, because I'm literally repeating myself. So to spoil it, like odds are a loop is probably going to be our friend here. And so in fact, in C, we have those features as well. So in the world of C, we can implement some of last week's same ideas in a few different ways. These are a little more mechanical, but suppose we want to repeat something literally 3 times. Scratch gives us a repeat block with an input, so easy. C, and a lot of languages, is going to be a little more mechanical. And it's going to look ugly at first. It will take some getting used to, but it is a paradigm you will use again and again and again. This will become very rote memory before long. Well, the most direct translation of this Scratch code to C is probably something that looks a little something like this, whereby I initialize a variable, here called I, and set it equal to 3. That's the code equivalent in C of putting up 3 fingers. Then what I want to do is while I is greater than 0, that is to say, while I have at least 1 finger up, go ahead and do the following. And then once I've done that, for instance, say meow on the screen, I want to go ahead and decrement I and then do this whole thing again. Now, I could have called this variable counter for consistency with earlier, but it turns out it's conventional when you've only got 1 variable involved in your code and all it's doing is something simple like counting. You can go ahead and call the variable I for integer, for instance, but it would not be wrong to instead call I counter. But notice, too, that in this so-called while loop, as we'll start to call it, there is this parenthetical. And that parenthetical is actually itself a Boolean expression. But unlike an if statement, whereby the Boolean expression is evaluated just once, and if the answer is true or yes, you do that thing, the Boolean expression in a while loop here in C is evaluated again and again and again every time you go through the loop to check if you should keep going through the loop. So for instance, if the goal at hand is to say meow, well, of course, the comparable C function is going to be printf, and I want to print out on the screen meow, followed by a new line. Well, what's going on? Well, again, I initialize I to 3. I then check, is I greater than 0? And of course it is, because effectively in the computer's memory, 3 fingers are up. I go ahead and print out meow. I decrement I, which means to put down 1 of those fingers, and then I check the Boolean expression again. Is 2 greater than 0? Of course it is, so I print out meow, and then I decrement I, putting down 1 more finger. Then I check the expression again. Is 1 greater than 0? Of course it is. I print out meow, and then I decrement I, and now I'm down to 0. I check again. Is a 0 greater than 0? Well, no. And so the loop will automatically, by the definition of how this C code works, terminate for me and proceed to any other lines if there are more lines of code that I've written. So how do we actually implement this then in code and get it running? Well, it's going to be pretty much the same idea. Let me go back to VS Code here. I'm going to get rid of all of this copy paste. And inside of my main function, I'm going to do exactly what we saw. Int I equals 3, semicolon. While I is greater than 0, then go ahead and print out with printf, meow, \n. And then be sure you decrement I. And notice that lines 8 and 9 are not only indented, they are inside of that while loop, so to speak, which means they will both happen again and again and again, because what's happening in code here is those curly braces are kind of like the yellow pieces that are hugging the other puzzle pieces in Scratch. It will keep doing this, 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 but every time through that loop or cycle, this Boolean expression will be checked again and again and again until the answer is false, at which point the computer is going to jump to the last line. And if there's nothing left, that's it for the program. No more to be done. So same exact idea in Scratch, even though it's a little more mechanical. So that's how we might implement this. And you can think of it sort of these variables. This is perhaps a little gratuitous, but let's do this. So if you have a variable inside of a computer's memory, and that's a detail we'll get to in more detail before long, you can really think of it just as like a container that stores values. So for instance, this clear plastic bowl, it can be thought of as a variable. It just stores values. And right now, there's obviously 3 stress balls in it, so it represents the number 3. So what's really happening in code like this is we've initialized I to 3, which is this bowl. We're then checking the question on line 6, is I greater than 0? Obviously. So we proceed inside of the curly braces and we print out meow. We then decrement I. So for the sake of unnecessary drama, like that's decrementing the variable. So what's being stored in this container now is 1 less. We do it again, check the count. Nope, 2 is greater than 0, so we keep going. Meow, decrement I, check the variable. 1 is greater than 0, so we print meow, decrement I. We check the condition again. I is not greater than 0 because 0 is not greater than 0. And so the rest of the code stops executing. I'm not sure if that was any more effective than fingers on my hand, but we had the ball, so same exact idea. Variables are just storing some value, and incrementing and decrementing would just be adding or subtracting stress balls in this case. But there's other ways we could do this. In fact, let me zoom in on my code here. And it's not really conventional in programming to count down. Like, nothing wrong with it. It's just not really a thing. We would typically count up. So we could alternatively do this. Set I equal to 1 initially. So we count 1, 2, 3, like a normal person. And we can change our condition. If I'm going to count from 1 to 3, what should my comparison be in my Boolean expression here?
Less than 3.
I is less than 3? Less than or equal to 3, I think. So if I is initialized to 1, we're going to go through this 1 time, 2 times, 3 times. I is going to eventually get incremented to 4, but at that point, 4 is not less than or equal to 3, so it's only going to execute a total of 3 times. But there's still a bug in this code. What other line needs to change? Yeah, so line 9 needs to become plus plus. So this code is just as correct, and honestly, reasonable people will disagree. Your TF might say, do it this way and not this way, but like this is still correct, but it's not the most conventional way. As per last week, computer scientists and programmers generally actually start counting from 0 by convention for reasons we'll soon see. So the better way, the more conventional way, arguably, would be always start counting from 0, count up to, but not through the number you care about. And so this form of the code is probably the most popular way to do it. Start at 0, count up to 3, but not through 3, as with less than or equals than. All 3 are correct. Can't really do counting up as easily with the bowl without picking up the balls, but the exact same logic applies. And in fact, this version of the code is so commonly done that there's a different way to implement it all. There's a similar way to implement it all together. In fact, this code here, same exact thing, repeating 3 times, because it's so commonly done that you want to initialize something to 0 and keep doing something until like the value 3, you can actually use a different preposition for, which is another keyword in C, and it looks a little more cryptic, but it just tightens things up. This is what's called a for loop. Previous is what's called a while loop. And honestly, even though it probably to the newbie still looks just as cryptic, it's just a little tighter because you're expressing all of these ideas on one line. You specify the variable you want to create and initialize. You specify the Boolean expression you want to check again and again. You specify what increment or decrements you want to happen. And confusingly, you do use semicolons here, not commas. You do not put a semicolon here. You, of course, don't put them after these things. You generally only put them after functions thus far. So we do have one semicolon here. But in short, this you'll get more comfortable with. This is how I, for instance, almost always write a loop, but it's doing the exact same thing mechanically as this. Same thing as counting on your fingers. Same thing as counting the stress balls. There's just different ways to express the exact same idea. But there are ways to screw up. So in fact, let me go ahead and do this. Suppose that we'd like the cat to live as long as possible, and we don't want it to stop meowing after just 3 or a finite number of times. How can you do something forever, again and again and again? Well, let me go back into VS Code here. Let me delete all of the code from earlier. And let me go ahead and say, while something is true, I'll come back to that. Let's just go ahead and print out meow, \n, ideally forever. But what do I want to put in here? Well, if I want to do something forever, I could do something kind of stupid like while 1 is less than 2, which is always going to be the case. Or while 50 is less than 51, which is always going to be. I could just ask an arbitrary question, but like arbitrary, not good in general. Like you should have meaning behind your code. So if you want the expression to be true all of the time, just say while true, because true is not changing anytime soon. If it's literally true, it's always going to be true. The only caveat is to use this trick for now. You will need to include the CS50 library, which for today's purposes makes that possible. But there's a problem, of course. If the cat's going to live forever, if I do make cat /cat enter, like you can very quickly lose control over your terminal window. And you can see like the meows are flying across the screen, at least based on the bottom from what we're seeing. Like this cat will never stop meowing. And this is either a feature or a bug, so to speak, depending on how long the cat here should live virtually. But how do you terminate a program that is out of control like this infinitely? So one of the takeaways for today is Control-C is your friend for cancel or interrupt the program. If you ever sort of lose control over a program because you've got intentionally or unintentionally an infinite loop, you can go into your terminal window, hit Control-C, sometimes multiple times if it's ignoring you, and that will break out of the program and just essentially force quit it, like in Macs or PCs. But let's make one improvement here still. The last thing we did with our cat in Scratch, before now we'll take a break in a moment, was we defined our own functions. And recall that we did that to abstract away the idea of meowing, because Scratch didn't come with a meow puzzle piece. C definitely does not come with a meow function. We have to implement it ourselves. So quickly toward the end of week 0, we did this. Define a function called meow that just plays the meow sound. And now we have a meow puzzle piece we can use and reuse. In C, we're about to do this. And this is going to look a little cryptic, but it's going to lay the foundation for future weeks when we do this even more. I've got a meow function, weird mentions of void. That just means there's no input and there's no output for this function. It just does one thing simply, and that one thing is printf meow. So how do I use this here code? Here in Scratch is how we used it last week. When the green flag is clicked, repeat 3 times the meow function. In C, it's going to look like this, int made void and all of that. And I can use a for loop, a while loop. I'm copying and pasting the for loop version of the code. Set I equal to 0. Make sure it stays below 3. Increment it on each iteration or cycle, and just call meow. So what's nice here is that we have fairly simply a way in C to create our own functions called meow or anything else that lines up perfectly with what we did in Scratch. We'll take some time to get comfy with the syntax and remember it, have to look it up frequently for reference, but let's go ahead and actually do this. If I go back to VS Code, clear my screen, let me hide my terminal window temporarily, let me go ahead and invent this meow function. Per the code earlier, I'm going to go ahead and do this. Void, meow, void. And again, the 2 voids mean no input, no output. It just does one thing well.